When you're looking out on the range and trying to manage animals, it's really important to know if you can manage where they are, not just what they eat, but where they are. And so today we'll talk about habitat selection and learning. We've talked about diet selection. We know quite a lot about that. We know less about habitat selection, so I think there's opportunities to learn. This is Integrated Rangeland Management at the University of Idaho, and I'm Karen Launchbaugh. I'll tell you what I know. So how do animals know what good habitat is, assuming they have to select good habitat to be successful? Well, there's been a lot of theories over the years. At first, we thought maybe animals were just born knowing what was good or bad. Then there was this theory that was called the neural template, this idea that maybe they don't know exactly where is good or bad, but they have this picture of what is appropriate habitat. There's a little bit of evidence from some studies with wildlife that animals are born with an idea or a picture of what appropriate habitat is. Another idea that has to do more with learning is this idea of habitat preparedness. Yes, animals might learn what habitat is appropriate, but they also have physiological and physical abilities to use some habitats more than others. Some animals might be really well adapted to using wetland habitat as opposed to upland habitat because of their physiology and their physical abilities. So that affects what habitat is actually usable. We talked about actual and potential habitat. This might affect that, whether what is potential habitat and what is outside of that. Then finally, the learning part. What habitats are punishing or reinforcing based on an animal's physiology and physical? So that's what we're going to study today. Habitat preparedness is really a key. This is an example from Hoover Dam, and this does not look like a foraging place, but those little bumps that you see on the dam are goats. They're mountain goats, and they are using this dam. They're actually harvesting salt, and so it's pretty amazing. How could they possibly develop the ability to use that habitat? They were obviously prepared to do it. And now let's take a closer look at that. This is actually an example from Italy, but it's the same thing where goats are using a dam. So in that previous video, there were some pretty good examples of how animals could develop really extreme skills to use really unusual habitats. Now we're going to go to Montana and look at some studies that Derek Bailey did in Havre, Montana on the Thacker Ranch. And this does not look nearly as extreme, but there's quite a lot of variation in slope on this ranch, and Derek was interested to see if maybe some cows were more able to use upland habitat than low habitat. So what he did is he had a group of Tarente cattle and a group of Hereford cattle, and he just looked at differences in their ability. And so what he found was when he looked, these dots on the maps, either the red or the purple dots, are locations on the landscape that he got from GPS collars. And what he found was Tarentes, which were cattle that were developed in the French Alps, they actually were able to use steeper habitat than Herefords. So there was some idea that genetics might play a role, and Derek has done significant work since this and has found that yes, there is a genetic basis for using habitat. While Derek was working on the ranch, he also identified some animals that were what he calls bottom dwellers and some that were upland hill climbers. And when he divided animals into hill climbers and bottom dwellers, what he found was that was really consistent. So he looked at animals. This is just an example of 4, but you'll see that the animals that are hill climbers, not only did they use higher elevation, they used it consistently. This was over a 13-week summer. So throughout the summer, the hill climbers actually used higher elevation than the bottom dwellers. He also looked at how steep a slope they would use, and those hill climbers also used steeper slope. So again, just four cows, but good examples that they might vary from week to week, but overall they're very consistent in their habitat use. One interesting thing was that the bottom dwellers actually walked farther. Okay, they were on more level terrain, but they did walk farther every day than the hill climbers. A study to look a little more closely at how animals will travel from water was conducted in New Mexico, and they looked at Brangus cattle, which of course they're Brangus, they're Brahma and Angus crosses, so they have Brahma in their background, which is a subspecies of cattle that is a bit more water efficient because they were developed in very wet areas in Africa, whereas Angus and Hereford were breeds that were developed in the British Isles up north where it's real moist, and so they don't have that water efficiency. So Dr. Winder compared Brangus to Angus and Hereford cattle, and he found that indeed Brangus did travel further from water, and because of that they consumed different diets. Their diet was actually higher quality. They traveled further, but they were able to access better forage. So when we see animals on the landscape, it might be unclear exactly why they're there and what is the relationship between the forage that's there for eating in the diet and the habitat selection. Well, conceptually, Dr. Heitschmidt and Stuth laid out some ideas that maybe animals are making decisions on a whole hierarchy of levels. These cows might be grazing here because it's a nice landscape. It's a nice space on the landscape that's pretty level. There might be a nice plant community there. Or maybe they're really just seeking an individual feeding station, an area right in front of their nose, or maybe they're just being driven by individual plants. It's hard to say whether they're looking at the landscape or the feeding station, the individual plants. It's undoubtedly a unit of both of those. You might think of it for yourself. You might want to go for lunch somewhere, and you're going to go to some place that has some nice ambiance, or maybe your friends are there. Those would be the landscape sort of plant community. It has a nice menu. But then you might also be going there because there's one thing on the menu that you want. There's one plant, there's one food item you want. And cows and sheep and goats and wildlife are doing the same thing on their environments. Do animals learn how to use habitat? There might be three ways that they would learn. They might have individual trial and error. They might have some early life experiences. We know that in diets, that's very important, early life experience, but peers might also influence them. So here's a picture I took of a friend's cattle who were, they were going across the Imnaha River. And I swear that this looks like something that would take some real skill in animals to learn to do this. Any cow I ever owned would not have gone across that river, but these cattle, Mike's cattle, they'd learned this skill. How did they learn it? Well, they had to learn from some individual trial and error. It probably started when they were pretty young, and of course they were pretty influenced by their peers. Once their peers started going across the creek, they did too, and probably the river wasn't as high when they first started learning those skills. So some combination of early life experience, trial and error, and peer influences probably play a role. Here's another extreme example. You may have seen these pictures. It's pretty frequent that people will send pictures from Morocco with goats that are actually climbing in the trees. And so goats can use the forage in the trees by climbing up them. Now that's an unusual foraging skill. Again, it probably involves some trial and error on the individual animal scale. It probably requires some early life experience. Goats probably try it when they're pretty young. And then of course peers. Their peers do it and they do it. So combination of those three things. Now here's an example a little closer to home. This is on the canyon walls right south of Riggin, so on this little Salmon River. Really steep country. You can see that these hillsides are, 40, 30 some degrees, so really steep. And interestingly, those little black spots are cattle. So those cows must have learned how to use that country when they were young. They've had some early life experience, some trial and error, and of course they're there with their peers. So I would argue that these cattle are unusual and that they're really well trained to use that steep habitat, and that other animals from other parts of the world probably wouldn't be. We've talked about early life experience, but social models are also important in helping animals learn environments. The most important model, of course, is mother, because she's successful, she's genetically similar to the young, and she's there. These social models provide really critical information about the hazards and the resources, so the food, the water, cover, predators, things in the environment that will help the animal be successful. Interesting experiment done in southern Idaho by Dr. Larry Howery. He wanted to know if animals learn how to use habitats or if they are born that way. Do they have this genetic component of knowing what habitat is around them? So he did an experiment where he cross-fostered calves. So he was working in the Sawtooth National Forest, and there was a rancher that had told him that some of his cattle hung out on the Thompson Creek side of this allotment, and others hung out on the Maxfield Creek, and they seemed to have fidelity to those sides of this ridge. And he wanted to know if it was genetic or if it was learned. So first he had to make sure that what he had heard was true, and so the bars are, the light purple bars are really tall because this was a percent of observations of Maxfield cows that were on the Maxfield side. The Thompson cows were not on the Maxfield side, they were actually on the Thompson Creek side. So yes, it is true that these cows had fidelity to these sites of the landscape. And then he did the cross fostering. He took some cows and calves and he collared them first to make sure where they were hanging out, and then he cross fostered them, which means he took some newborn calves and he gave them to some cows from the other drainage. So he took some Maxfield calves and fostered or cross-fostered them onto some Thompson Creek calves. And you see this calf has a little gunny sack on it because that's how they do it. Right when they're born, they take a gunny sack and they rub it on the cow's real calf, and then they put that gunny sack on the adopted calf. So it's tough to do, but Larry Howery was able to pull it off, and then later on he looked at and observed cows that were either natural calves or cross-fostered calves. And what he found was the natural calves, so the cows with their natural-born calves, when they were born, they stayed with their mother. So in 1990, the Maxfield calves stayed with the Maxfield cows, and the Thompson calves stayed with the Thompson cows. Then when they became yearlings, just like teenagers, they started checking out the neighborhood. Some of the Maxfield calves went over, those yearlings went over to the Thompson side and vice versa. So they started to really use some larger areas and kind of look into the other areas in their landscape. At 2-year-olds, they still used a lot of area. There was a severe drought this year, and the drought was less, the stream on the Thompson side was a more stable stream. So some of the Maxfield calves, 2-year-olds now, started to move over and use that Thompson side. However, when they were 3-year-olds and the drought broke, and now these calves were mother cows, they started going back to their original habitat. They started using that same habitat they were born in. Okay, the question is that genetic or was it learned? To answer that question, let's look at the cross-fostered calves. The cross-fostered calves did the same thing when they were born. They stuck with their mother. Whether it was their adopted mother or their natural mother, it didn't matter. They stuck with their mother. When they were yearlings, they did the same thing. They moved out to another landscape just like teenagers do. When they were 2-year-olds, after the drought broke, they went back to their home territory. So the fidelity to a creek or to a landscape, in this case, had more to do with where they were born than genetics. So bottom line, habitat fidelity is based on experience, not genetics in this case. So in summary, a few things that we know about social models is that mother and peers do affect the habitat use. Animals tend to prefer the habitat where they were raised, and as they mature, they're influenced by their peers. When they're teenagers, they are moving around a bit more. Peers are important models to learn hazards and new resources in the environment. And then when the environment changes, such as the drought that occurred in the study that Dr. Howery did, that really influences habitat use. So social learning can sometimes also be maladaptive. The habitat was actually better on the Thompson side of the creek, but animals really never learned to use that. So the habitat selection can be maladaptive. Another really interesting experience about that fidelity, that site fidelity, and how important it is that animals learn the landscape around them was conducted by Dr. Derek Bailey from New Mexico State. And he had a situation where his home base is in New Mexico, Las Cruces, New Mexico. That bottom picture, they get about 9 inches of precipitation a year, and one year there was just a really bad drought and he needed to find some home for some of his cattle. So he had a friend over in Leona, Texas, and he took him over there. Now Leona is quite a different place. 41 inches of annual precipitation, much different. Both cases, the same kind of cattle, They were herded, so same kinds of conditions, much larger pastures in Las Cruces than Leona, but still similar kind of cattle. So what he did was he took some of his cattle from Las Cruces over to Leona for 3 years, and then he brought them back to Las Cruces, and then he asked them, how did you survive? How did this work? So here's what Derek did. He had some cattle in New Mexico, and because time was tough, he moved those over to Texas for 3 years. And then he brought them back. At that same time, he brought some cattle from Texas back to New Mexico that had never seen New Mexico. So he had 3 kind of cattle in the study. He had some natives, some of the herd that stayed there on the range in New Mexico for the whole time. He had what he called the tourists, the ones that were from New Mexico, and they went and toured around the beautiful rangelands of Texas, Leona, Texas, and then they came back in 3 years. So they were the tourists. And then he had some naive cattle, ones that had lived their whole life in Texas and came over to New Mexico. And here's what he found in those when he looked at how these animals use the landscape. And the interesting result is that the naive cattle stuck very close to water. So you see the little blue spots that name water, and the purple spots were the naive cattle. So they stayed pretty close to water, about 700 meters, 720 some meters. The native cattle were twice as far from water. So they were about 14 or 1500 meters from water. Those are the red dots, and you can see that they were quite a ways from the water. The tourist cattle, remember, these cattle grew up on New Mexico range, but after they went to Texas and came back, they didn't go as far as they had as the native cattle, as their cohorts that had stayed in New Mexico. So the bottom line is life experience, whether right at birth with mother or later in life, can influence how animals use landscapes. So the individual experience of animal is really important in terms of the skills they learn, but also how they use landscapes. So we know that animals are choosing different parts of the landscape, and we know that there's something in their experience that is influencing where they hang out. We know that cows that stayed in a habitat are familiar with it, have different habitats than those that went away for a while or those that had never been in that habitat before. So what is driving that habitat selection? Let's go back to our model of behavior, where we know that behavior depends on consequences. We know that animals behave, they select a habitat, and there's some cues of being in that habitat or eating that food, and then there's consequences. So let's tie habitat and diet selection together. If an animal eats a food and tastes it, they get consequences, and the consequences are positive, they form a preference. If the consequences are negative, they form an aversion. But let's focus on what are those cues and what are those consequences. We know that not all consequences are created equal. There was some really interesting work done by some operant psychologists that said that consequences are not equally tied to cues. So this theory is called Cue-consequent specificity. Bottom line, tastes and odors are related to nausea, and that's what drives food selection. So food preferences and aversions are formed because of our relationship between the flavor of the food and the odor of the food and the nausea that is experienced. That's the gut defense system. Sight, sound, touch, and to some degree odor are related to pain and pleasure, and that forms place selection. So place preferences or place aversions are a relationship between sight, sound, touch, and then the consequences, which is pain or pleasure. That's the skin defense system. Odor is somewhere in between. Odor is interesting because it plays a role in both the gut defense system and the skin defense system. So animals might smell a food and decide that's a good food. There also are odors associated with a place that make a place appealing. So the smell of a place can make it positive or negative. Again, animals associate smell and taste with gastrointestinal illness. They associate sight and sound with electric shock or feeling bad. That's a place aversion. Go back to our model again. Now we're going to apply this to we're going to apply this to habitat selection. Animal uses a specific area or a specific habitat. There are some cues that they're paying attention to. There's some consequences of being in that habitat. What are those cues? Well, I would argue that because of the Cue-consequent specificity model, I believe the animals see the habitat, they hear it, they feel it, they might smell it. Taste would be less important for habitat selection, but it might play a role in the kinds of foods that are there, and that the foods in the habitat might make it appealing. So animal sees, hears, feels, smells, understands the place, and there's some consequences. What would be considered good consequences of being in a behavior, or being in a habitat? I would say security. If an animal feels secure, relaxed, thermally comfortable, it's not too hot, too cold. So think about the place that you would go if you really, really liked the place, your favorite place. It's probably a place where you feel secure, you can relax, it's comfortable. If a habitat has those kind of consequences, the animal would form a preference. They would tend to stay in that habitat or seek it out. What about the other side of the coin? Animal sees, hears, feels, smells a place, and there's consequences of being there. What would constitute negative consequences? Think about places you don't want to be. Where would be what would be the consequences of being in a habitat that's bad for an animal? Well, maybe fear, maybe it's painful, maybe it makes the animal weary, maybe they're hot or cold, maybe they're hungry or they're ill. The hungry or ill, that's because of the foods in the environment. So there is a relationship between diet selection and habitat selection. But an animal comes to a habitat and they don't feel good. They feel hot, cold, pain. They're in pain, it's fear. They form an aversion to that place, and then they would learn to avoid it or leave it. So that's the whole model. The thing that's different in the model is the cues and the consequences. Let's focus a little bit more on those consequences. Positive consequences of being in a habitat for an animal might be that there's good forage there and that they become satiated. It might be that it's thermally comfortable, not too hot, too cold. Maybe it was easy to get to. Perhaps there's no predators, no sign of predators around, so they feel that they're not at risk. They feel comfortable. Might be few pests like insect pests, and then also there might be other animals around, their mother, their peers, other members of their cohort that they feel comfortable with. And aversive consequences of being in a habitat might be things like inadequate forage, it's too hot, too cold, too windy, it was difficult to get to, predators or pests are there, and then also there's no friends, there's no conspecifics. So those would all be the things that we could change in habitat to help animals prefer or avoid habitats. Let's think a little bit more about the cues that animals use, at least from a distance when they're trying to find their place in a habitat. There might be many natural cues they would use, such as, a hillside, how steep it looks. It might be a riparian area. There might be some more vegetation down in the riparian area. Maybe it was burned so that it's black and they want to avoid it now, but maybe they'll remember that in sometime in the future they want to go back to that habitat because it will be green. Also, if your conspecifics there, other members of your herd are there, might be more comfortable. There's also a lot of man-made cues. Cattle, horses, we often think about cowboys as pushing cattle, but an actual herder is also an important part of the community, and that a good herder is moving animals towards a preferred habitat. So the actual horse and the cowboy might be a cue. Windmills across the landscape, fences, roads, all of those human-made cues might help animals see the landscape, and they might form preferences for some of those places. So what might they remember, and where those visual cues play in? Cattle, their spatial memory is comparable to other mammals and birds, so we know where we are in the landscape, and cattle are certainly good at knowing where they are in the landscape. They'll remember that for years. I just remember a story when I was growing up. I had moved some cattle to a new pasture, and I knew that the gate was closed at the other end of the pasture, but I thought, they haven't been back in this pasture for a year or more, so I'm going to put them in there and then I'll just walk over and close that gate. Well, of course, I got through the first gate and the cattle just made a beeline to the other gate. And so I ended up having to herd cattle back into the pasture because I thought maybe they wouldn't remember where the gate was. Well, now I know that they remember where the gate is just as well as I do. So they have really good spatial memories. The visual cues are greatly enhanced by the animal's ability to use the landscape. So we know that if you want animals to use certain parts of the landscape, they could use signs. We could use visual cues to tell them where to go, especially in variable environments. This picture on the right was one by Dr. Howery, and he was trying to see if animals could learn where he put treats out on the landscape. So there's a little orange traffic cone, and he put these out through the landscape, and it was a sign to the animal, hey, here's a good patch of food. So he put some grain or some cake around it, grain cubes, And the animals quickly learned that orange pylons were a cue to go and find a treat. And so those kinds of visual cues can really help animals learn the landscape. So how might we as managers use those visual cues in the field? Well, we might use them to tell animals where to go, or where the gate is, or where to cross the creek. Any behavior on a landscape that we want to train, we could train. A fellow rancher that I know, he had the idea that he wanted to be able to use mineral supplements to put cattle out across the landscape and kind of spread their use out. But he knew that they wouldn't always find these little tubs of minerals, so he put these big. He was a welder, so he just took all this old iron out of his shop and he started putting it up on the hillside where the mineral was. So the animals would hear this clanking, so they were kind of wind chimes, big metal wind chimes. So the animal would hear it, and that would direct them to the sight and sound of that wind chime, and then at the base of it would be some mineral. Well, that worked really well. The cattle easily learned that the sight and sound of those wind chimes, that meant mineral, and they'd walk up the hillside and use the mineral. The only downside was people driving by on the road also thought they were really cool, and perhaps my colleague was a little too good a welder, because most of the wind chimes were taken as yard ornaments. So animals can use visual cues. We as managers could find ways to use visual cues to direct animals across the landscape. Spatial memory is how well animals remember things. Just to distinguish between a reference memory, that's the memory of how the landscape is laid out. So that's when the cows went to the other end of the pasture to get to the gate. That was their map. That was their reference memory. Working memory is that they remember things that happened recently. So when Larry Howery was putting out the little pylons, the traffic cones, to tell animals that there was good food there, the animals' working memory would tell them, I ate all the food here today, so I'm not going to go back there tomorrow. So they have this working memory that is usually fairly recent and just tells them what habitats were good or bad. Going to finish up with habitat use skills. Can animals develop physical skills to improve their use of the landscape? Undoubtedly they can. Animals can develop habitat use skills to use really steep slopes, like these cows from Riggins that learn throughout their life to use these steep slopes. They could develop those skills, and then that would change their experience on the landscape. So based on what we know, once an animal has those skills, that habitat is not as aversive. It's actually maybe more appealing. So animals could gain an ability to use really steep slopes. And maybe even they would prefer those slopes, because maybe those slopes are associated with better food and they're familiar to the animal. So getting better at using the landscape might actually make it easier and more reinforcing, or more positive reinforcement from using those steep slopes and far distances from water. Key points. Bottom line, where do habitat use patterns come from? They're inherited by one's species and breed, so there are some inheritance of physical abilities that influence how an animal uses the landscape. They're certainly also learned with social models, and mother again being very important, but peers also. And then finally, they are based on individual experience. What are the positive or negative consequences of being in a habitat, and how do those consequences change behavior? So just remember, sight, sound, and smell are related to pain, comfort, or distress in a habitat. And managers can change these habitat consequences to change habitat cues. So throughout this class, we're going to see how could we change habitat use. Again, if you want more information on these ideas and some of the work of Dr. Bailey and Dr. Howery, go to behave.net.